So to throw a little curve in, pun intended, we're going to need to use a lunchbox component, and I'll explain what that is in a minute, that allows us to it greatly simplifies this whole description of geometry. We could just divide it off, but we end up with some extra nodes that we have to create, and I think it's a bit confusing. So I'm going to encourage you to download Lunchbox, which is an add-on. Lunchbox I'm showing you on the screen here, and if we go down to curves, it has a divide curve, and then it gives a lot of nice outputs. It gives the points, it gives parallel planes to that, divided off. We don't need all of that, but we're going to get that anyway, and we're just going to pull the points off for this one. So the way you download Lunchbox is you go to Packages, search a package. It takes a minute to sync up before anything shows up on the screen, so there's no point in typing in until it gets happy with you, but I'll see if we can sneak in. Lunchbox is one word. Alright, so Lunchbox with Dynamo. If I click on it, you'll notice that it says due to persistent managers is moved to a new installer complying with the Grasshopper version. So you just copy this URL and it will download Lunchbox and install it for you into the package. And they discourage you from using this technique of directly installing it. So if you want to see how this would, and of course they don't have copy and paste. So you have to type it one for one here. So give that a shot. If you have any problems, you can just email me, but I don't think that's going to be an issue. And now you've learned how to install an add-on to Dynamo. And we're going to use a couple of them. DynaShape is a really powerful add-in to Dynamo. Anyway, so once you've loaded that up, drag that onto your desktop, and you can now start to divide these lines off. And we're going to use a list create to do that. So list create, and we'll just create 3 inputs for it because we're going to have 3 lines. So we have the first line, second line, and the third line. And we'll feed that into curves. And now they're all divided off for us. So if I'll just zoom around here so you can see what we've got. It looks a little confusing. There we go. So now we have all of our shapes with all of our points defined for it. And now we can actually start thinking about how we could attach our adaptive component. So let's think about that just for a minute. First of all, we have those points. So let's look at what that actually looks like, what the list looks like. So I'm going to do a watch box. So, and I hate when that turns into a hand. And I'm going to drag the points into the watch box. And now you can see we have these list of 5 points, which are how many points we want, but we have 3 lists of 5 points. So we have, you know, the 1 point in a list, 2 points in a list, 3 points in a list. So what we really need to do is transpose those so that they're actually in the other order. We want 1, 2, 3, then the next series all the way through to how many components we have. And there is a list transpose function. And let's see if that'll show up quickly. Dot transpose. And we'll plug that list into this one. And we'll transpose it. And now you'll notice what we have are, and let me just zoom in there if I can. Now we have lists, which will be 5 lists. Actually 6 lists because there's the endpoint or the 0 point. But each one of those has the 3 points that we need to define our shape. And I can further illustrate that by plugging this into the points. And now we have our polygons, except we have, it looks like, no, I guess that's correct. We have all of our, they're not filled polygons, so it's a little bit hard to see. And if we hadn't done that list transpose, if I was to plug this in like that, we'd come up with a a much different kind of output. So that gets us to the point now where we have all of our polygons. I'll pull the watch box out now. And we'll leave it there in case we need it later. And we'll put up our polygon by points here now. And the next thing I think well, let me see here. I'm going to just review what I've got on my notes here. It might be time to look at how we would mirror this component tree. So we want exactly the same thing happening on the other side. And Revit gives us a nice tool to do that. So if we go to geometry, and I'm going over here so we can see all the functions that we have, and I'm not seeing the mirror. Well, let me just try mirror alone. I really find the search boxes a little bit. Geometry mirror. I'll select that. So now if we plug in our, we won't plug in our, well, we'll do our polygons anyway because that'll make it clear. But we need a plane. We need a reflecting plane to kind of bounce it off of, just like a mirror would be. So we're going to need to actually create that that mirror plane. And the way we're going to do that is we're going to first of all figure out how to see what we need to do to get a plane. So I'm going to type in plane, and we can have a plane of all kinds of different definitions here, but we want one that has a plane by origin and normal. And I lost it. Let's try that again. And now I've got two of them. And we need it, so the origin now is defined as a 0, 0. And if we mirrored it right off of this, there'd be no space in between the systems. And we actually wanted to have a little bit of a system. So we want to actually transpose that origin a little bit. So we're going to select another origin point. So we already have the 0, 0 point. I'll grab a new points by coordinates. And we'll put that point in here as the origin point. And it's not going to move anywhere, because what we want to do now is just actually translate it. We're going to take this point now and move it. So let's put a slider in. So I'm going to use I'm going to type for a number slider. And we're going to move in a negative direction. I know that already. So I'm just going to go ahead and put let's say negative 10 to 0 and steps of 1. And we're going to rename this right away. And we'll call it wing spacing. And I think we want to move in the, I think it's the X direction. So let's just experiment with that. All right, so now we have our point that we're going to mirror our framework, and we need a normal. And a normal is defined as a vector in the direction that we want. And we want to reflect it off of this kind of y-x plane. So let's look for a way to do that. So we're going to get a plane, it's called a plane normal. And what'll error out because we haven't defined that plane yet. So I'll go for plane, and I want the YZ plane. So I selected that. And I know a lot of this is a little bit on the confusing side the first time we go around it, but so what we've done is now all of this work, all of these components right here, which I actually could just gather up together and call a group. put a box around them. Oops, I'm not able to, hold on a second. Create a group. And we'll call this mirror plane. And I'll connect this plane up again. I accidentally unwired it. And now we have our mirror plane, and we can slide it and flexibly move it. And let's plug it now into our geometry, and voila, like magic, now we have a way of reflecting all of our geometry that we've already created on the other side. So we're well on our way of being able to quickly duplicate and then modify our curves. So I think the next thing we'll look at is actually what this would look like in Revit. So let me just close this down, and we'll go to level, this project here, which is, this is the, oops, excuse me, sorry about that. I'm going to go ahead and save this project. I'm not getting the dialog box up on my screen. Hang on a second. And I've got to leave this somewhere. Well, I can leave it as just demo. M7. And let's just put that out at the desktop. And then let's grab a 3D view. So this is the first, this is the only thing that's in this project environment right now. And I'll just flip to our 3D view so you can see what we've got. All right, so we've got the exact same thing happening inside of Revit now. So Dynamo has defined all of our points, created polygons out of them, and then given us a nice reflection of those polygons. So when we pick it up next, we'll look at actually applying an adaptive component to these polygons.